Hi, this is my week 4 project on the MATLAB composite body for the surface area and flux. So in previous weeks, I had a pretty similar geometry to what I'm using this week. I made two main changes. One, I swapped out the center rectangle for a cylinder because I wanted to be more difficult and have, this plane that has the intersecting boundaries where if I took that bottom body and did the full square versus the circle, there would be too much surface area accounted for in the typical way, so I wanted to go through that process. And then it was also easier just to make it symmetrical about the center so that I can make these two really easily related to each other because they're symmetrical. I figured I'd start off showing the results for my body and show the two scalar fields that I got and the surface area 475, the surface area, the flux, which was calculated by MATLAB. I didn't verify that by hand, but I showed the equations in the slides, and the volume of the body, which I calculated last week, but I also verified with CAD this week again, and we'll see that later. Body 1, I chose the bottom frustrum. This is how I've been using parametrics to define it. This is how I define it by hand. I went through and I only show in the slides 3 of the faces because 1, 2, and then 3 unique faces in terms of surface area, because 3, 4, 5, and 6 are the same essentially. And then 1, what I'm doing is I'm counting this full area, and then when we do the cylinder, I'm counting that area as negative. And same with the flux, we'll talk about that. So the first one, we just see that the normal vector would just be straight up. I went through and I did the surface area integral, and then the flux integral based off of just a plain scalar field of u times v times w, which is the x1, x2, x3 essentially. So this would be that flux integral that's calculated by the MATLAB code. Similarly for surface 2, you can see it's just going the negative E3 direction. Here's our area based on, and that makes sense, right? It's just a square with length b in this problem. Same with the flux. This one's a little more complicated, and I just treat it as typical for 4, 5, and 6. I don't show the work, but it's essentially the same. And this one's a much more complicated flux integral just because of the nature of it being like a slanted edge versus just those flat planes we saw before. Similarly, I'm showing body 2, the cylinder. This is how I use the parametrics to define it. We've been seeing a lot of cylinders in previous weeks, so this shouldn't be too surprising. Very similar to the example we went through in class. Here's your flux integral. Here we know that it's going to be a cosine sine function because it's not just in one direction like the flat planes. And here's our flux integral. I calculated the surface area by hand. I also used MATLAB to verify the surface area and the volume. You'll see 475. Here I'm showing the results again. You'll see 475. The flux we didn't have to verify by hand this week. And let me just show you the code working real quick. So this is when I run it. My computer takes a second on this. And here's the plots from this week. So you can see the same plots we saw in class. Vector field was UV, and it was defined as like from -2 to 2, or -a over 2, -a over 2 in the a over 2 direction. Which that doesn't make a lot of sense when I say it, but you'd see it on a graph. All right, thank you.